Okay, so today we are going to talk about the time-lapse analysis in Imaris. We will start from the basic tracking today, and for next sections, we will move to more advanced part. Again, I'm Arsene from Taiwan. I'm sales and application specialist, cover rest of Asia, which is APAC Pacific, Asia Pacific, except China and Japan. If you have any questions related to Imaris, you can feel free to email me directly via this email address at dachang@biplan.com. So here is today's learning objectives. Today, I will show you mainly about how to do the automatic tracking in Imaris. I will focus on the algorithms and the optimized settings for your tracking. Then I will also introduce the semi-automatic and manual tracking, which is how to add missing tracks after automatic tracking is done, or you just do manual tracking from the very beginning. After the tracking, I will show you how to do the result visualization, which about different displays for the tracking results and the time plot of track statistic. Yes, that is the topic we will cover today about the basic tracking. So when we talk about the tracking analysis, here is the overview of the steps in Imaris. First step is always the object identification, which is generally called segmentation. In Imaris, we mentioned before, we can use different tools for different applications for the segmentation. These include spots, surface, even the cells or filaments, which we will introduce later. But today's session, I will use a spot or surface to start from. And after the object identification, we can start the tracking. In Imaris, we have different algorithms for different type of movement. So you can, depends on how your sample moves, we can choose different algorithms in Imaris for better tracking. And of course, we need to set up some tracking parameters to have a better result. Then after the tracking, we can use the filter tracks to filter out the relevant data. For example, sometimes you will see some of the relative short tracking length result, which may be coming from the noise or background or some irrelevant objects. In that case, we can use the filter tracks to filter out only the good data, which is maybe the longer tracks or whatever other statistic you would like to use. And step 4 is to visualize the result. In Imaris, we can display the track result in different ways, and which you may want to show your data in the most informative manner. And step 5, edit tracks and objects, which is to correct the mistakes from the automatic tracking. So usually our image is not so 100% ideal for automatic tracking algorithms. So in that case, we may see some mistakes. This step is to correct those mistakes to get more accurate results. The last step is to quantify, export, and interpret the results using the statistic tab. Or in the end, we can also use a module in Imaris called Vantage to plot your tracking result. And for the Vantage module, we should have another session just focus on that plotting module. So in the algorithm, so I will just try to introduce the algorithms in my PowerPoint slides. Then we will go to Imaris for hands-on. So in Imaris, we have, I think we have total five different algorithms we can use for the tracking. First one is the Brownian motion. So if your sample or objects are moving without a specific direction, means the no discernible pattern, then we can use this Brownian motion algorithm. We can try to use this Brownian motion to let Imaris track your data. So basically, Imaris look for the object in a specific radius, then try to connect them. This is Brownian motion. Option 2 is autoregressive motion, which usually is more for biological samples. When your objects with more or less continuous motion, for example, like it's keeping the same, moving to the same direction, then we can try to use autoregressive motion algorithm to track your object. So basically you need to give the maximum distance of travel to Imaris, then Imaris will try to look for next object according to the settings of maximum distance and also the spot size and the radius, etc. Option 3 is autoregressive motion expert, which is based on the autoregressive motion, but also take into consideration the intensity. Now, this is suitable for objects in your sample that come very close together, but have different intensities. So usually this will take more time if you use this mode. So usually we will start from the Brownian motion or autoregressive motion. Then if you see the result is not so good, then we may consider using this autoregressive motion expert mode algorithm. Option 4 is connected components, which is very straightforward. If your object in the next time point is overlapped with the object in the current time point, then Imaris will try to connect it. So only the object is overlapped will be connected. And this algorithm only works if the time resolution is very high. And also it can analyze the division and the fusion of the object. So like this division, or if there is a fusion, this algorithm can also analyze. The last algorithm in Imaris is the Lineage. So Lineage is especially for events such as cell division, in which the splitting, I mean, here may be some mistake, there's no merging, so only the splitting. So it only detects the division used based on the autoregressive AR1 process, then it can detect the cell division or some split event. Okay. So here, maximum distance value is used for connecting point, like the basic autoregressive, but when there is a division, then this lineage algorithm can also detect if there is division. So basically, it considers the maximum distance and then the overlap between the existing time point and the next time point. And if there is a overlapping of the object in the next time point, then based on the distance and also some weight, Imaris will link the track together. So consider as the division. Okay, so this next slide is about the settings in Imaris, so which I will come back later. So for now, we just go to Imaris, and for tracking, I will try to use this swimming algae for, it's a 2D data set, but in Imaris, analyze 2D and 3D data set is basically very similar. So I will use this as a demo example. So here you can see I have a time lapse data, which here you can see the difference from the previous only a 3D or 2D data set. You can see a time bar here. So you can move your time point by dragging these indicators, or you can play one by one, or just play all the time points like this. So as you can see, obviously this is a time lapse data set, which with a lot of small swimming algae around this image. So let's say if we want to track this object, moving object in Imaris. So first step is always the detection. For this example, I think we can just use the spot for object detection. So we already went through the spot detection in previous sessions. So this one should be relatively easy. Just remember to check the track spots over time here. This option will be available as long as you have the time-lapse data and as long as you have the tracking module in your Imaris. So just check this one. And for this example, I'm just going to use the same spot size. Okay, so here, XY diameter, I should check about 5. And the background subtraction. Okay, a small tip here. So sometimes when you display 2D images in Imaris, then depends on your voxel size. Voxel size here is 011, so it should be okay. Because Imaris is also still trying to display this perspective view if you didn't change. Then sometimes even the 2D image looks like a little bit 3D effect. So if you want the completely flat 2D display, you should switch to the orthogonal view for the 2D images. Maybe it will look better for you. So we can switch between these two. For this one, it doesn't make a big difference, but for some data set, for different pixel size, you may see the difference. Okay, so I just use the perspective. Then here, continue. Then you can see there is a detection. Just make sure the threshold you set is good for most of the time points. Sometimes you set the threshold based on the first time point, but to the end, maybe there is some intensity drop or the difference in intensities. You may need to adjust this the threshold for most of to match or to fit most of the time points. Okay, looks good. So next, in number 4 steps, we can edit the spot if necessary, which means you can do the manual editing, like add or delete the spot you want before going into tracking. in Imaris. And this menu is exactly as same as the edit tab in the spot object properties. So should be relative easy. Okay, for this data set, it looks all good, so I'm not going to, all right, so maybe for the later demo, I will try to delete one of these spots. So here, if I want to delete, I just select and click delete. So I can delete one of or multiple spots. Or I can add one using holding the shift and the left click like this. Just a brief recap. All right, so for the demo purpose, I will delete this one and I will add it back later. So for the tracking algorithm, as you can see here, we have different algorithms here, and I introduced them in my PowerPoint slide. But if you want some, explanations in Imaris, then just remember right-click on this function and show help. Then we will have some description of the algorithms in our menu, as well as the other parameters. Okay, so we can try the Brownian motion first. So usually for a fresh sample, which I didn't do any analysis before, for the tracking, we will suggest to try these two algorithms and to see which one is better for that specific sample. So in here, I'm going to try the Brownian motion first. And as you can see, for the Brownian motion, we have the maximum distance and the maximum gap size. For the autoregressive motion, we have the same parameters to set up. Okay, so for the maximum distance means the maximum distance an object can travel between the time points. So basically, you have to go through the time points and see if you can find a fast-moving object. If there is a fast-moving object, then here it looks all quite average. So maybe I just focus on this one. Let's say if this one is moved quite fast, then I want to measure the maximum distance it can travel between the time points. Then we have to go to the slice view and fit. Okay, so maybe it's this one. Okay, so here I go to one time point and left click on the object, and I can move to the next time point and click again. So here we have a distance 3.5 micron. Then of course you can try to measure different ones and see the numbers for your data set. So this one is 4.6. Right, so you can try to measure a different object and see the difference in this number. So 4.97. So here I'm just going to use 5 or 6. So usually you can go slightly larger numbers, but not too large. Usually you will have to do the try and error to find the good numbers for your data set. So here I'm just going to start from 6. And this maximum gap size, this means, here we have to explain, sometimes during the tracking, your object will disappear from the field of view, either because of the focal strip or because of intensity drop, whatever reasons. But then if you didn't enable this gap size that says 0, then whenever the object disappeared, then Imaris will stop the tracking then once it appear again, then Imaris will consider as a different tracks. So in this case, for some data set, maybe you will see some discontinuous tracks. Instead of a long continuous track, you will see some small distance and small piece of track, which may not be good for you to visualize or to do the statistic. So in this case, we offer these options to do the gap close. So here, the number in Imaris basically means the tolerance that you give Imaris to not see the object. So for example, if you set 2, then even if this object is disappeared in the next 2 frames, but if it appears in the 3rd frame, Imaris will still try to connect these gaps, even without the object detection, but based on the maximum distance you are setting and the algorithm, Imaris will try to look for the similar object, if there is any, and to connect the tracks. So if you enable these options, you put some numbers in, and you may see a better result. But of course, if you give Imaris the tolerance is too big, for example 10, then obviously you will have a more inaccurate result, because maybe the Imaris will try to connect the other object into a same track. So here, maximum gap size, usually we recommend below 3, less than 3. So here I'm just going to use 2. Okay, so two frames for the tolerance. And there is an option for fill gaps with all detected object, which means in the gap without the object detection, Imaris will try to place a simulated object on the time point, on the track of the time point which there is no object. This is for some statistic to continue, and it depends on whether you need this statistic, for example, the specific speed or estimated position for this specific time point. Then you can decide to enable this option or not. All right, so here maybe I just enable it. So 6, 2, and go track. So you can see the track comes relatively fast. The result comes in relatively fast and relatively quick. And you can see already now we have some tracking result here. Okay, so it looks quite okay, which means we may have a good settings. Here, I may be able to show you if this number is too small. Let's say if I use 3, all right, for maximum distance, then you can see because I set the number too small, so these tracks cannot be connected in Imaris. There are a lot of small piece of tracks, which is not good. So maybe 4, like this. Okay, so if this number is set to small, then probably you will see this result, and you can go back here and try to use a larger number, like this. But sometimes even you set this in a relative large number, but under this algorithm, you still see something like this. In this case, if you don't want to increase this number more further, then maybe we can try to switch to autoregressive motion and to see if under the same settings, this autoregressive motion can give you a better result. So here we can see there is some small gaps here and here and here in Brownian motion. So if I try to switch to autoregressive motion and use the same settings, so maybe I can get a better result based on the smaller maximum distance measurement. So here, yeah, it looks better than than Brownian motion. Maybe because this biological samples is moving in the similar direction, so I can use this algorithm for better tracking with the same settings. So I'm just going to stick to the autoregressive motion. So basically I show you the difference between these two. And for the autoregressive motion expert, you can see there is an intensity weight. So basically this gives Imaris the weight to consider the intensity difference. But as in my PowerPoint description, this will take a longer time to calculate. So, but you just use it whenever it's needed. But usually we will try these two first. And for connected components, you can see there is no any options here. So it just very straightforward. It just connected the overlapped object in the different time points. And for Lineage, which you have the similar settings, but for the Lineage, we will leave it to the next session for the more advanced tracking. So here we focus on this autoregressive and this data set. Okay, so this step is to filter the track based on the track duration or whatever statistic you want to use. But most of the time we use the track duration to filter out the relative short tracks, which is maybe irrelevant for your statistic. All right, so here I just keep everything because it looks all good. Then just turn off. Okay, finish. So now we have the data finished the tracking. So here you can see the similar or the same tabs as in the spot detection, except there is a additional edit track tabs here, which you can manually edit the result. If there is any error, you can edit here.